So in this question, B option is correct because hydrogen radical is formed in this reaction, which is not correct, and over here hydrogen radical is there. This is not correct, and this is termination step, so it is also not correct. So propagation is B. This is termination. Question number 22. Malic acid is used in the food industry and for stabilizing drugs. It is the cis isomer of butene dioic acid and has the structural formula HO2 CCH double bond CHCO2H. Okay, stabilizing drugs, it is a cis isomer butene dioic acid. It has two carboxylic acid group which is attached on terminal, and carbon to carbon double bond alkene group is also present. What is the product formed from the reaction of malic acid with cold dilute acidified potassium manganate? So when cold dilute acidified manganate react, so it does not react with carboxylic acid, it reacts with alkene to form diol. So the compound is like this: HO2 CCHOH CHOH CO2H. Now identify this product in the options. Let's see. Okay, HO2 CCHOH. Yes, this is alcohol. This is second alcohol and carboxylic acid. So A option is correct. HO2 CCO2H. This is incorrect because this is ethane dioic acid. So in this compound 4 carbon atoms are there, so this is not correct. C option is incorrect because HO2C carboxylic acid over here, so one alcohol is attached with, so this is written as CH2, so that's why it is not correct. H carboxylic acid, in this compound ketone is formed, CO, which is not correct because ketone is when it further oxidized then ketones are formed, so it is also incorrect. A option is correct. Question number 23. Primary halogenoalkanes undergo hydrolysis reaction. Primary halogenoalkanes undergo hydrolysis reactions. Which reaction would occur most rapidly if they are all warmed to the same temperature? Primary halogenoalkane with undergoes hydrolysis. So this is, let's say, C2H5Br plus water. The compound is ethanol, C2H5OH plus HBr. So HBr is not formed because this is hydrolysis, sodium alkaline hydrolysis. C2H5OBr with sodium hydroxide. They are all warm to the same temperature. So same temperature because water is weak nucleophile, so it does not it will not react with the water at the same temperature. C2H5Br plus sodium hydroxide plus water to form C2H5 OH, ethanol plus sodium bromide plus water, plus sodium bromide, no water is formed. C2H5Cl, again C2H5Cl, water is weak, so C2H5Cl with sodium hydroxide aqueous. CBr is faster reaction with CBr, while CCl has slower reaction. So, in the question, the which would occur most rapidly. Ethanol is formed with this reaction also, but water is a weak nucleophile. So, that is why this reaction will not occur rapidly. Sodium hydroxide is strong nucleophile, so that is why it occurs. This reaction will takes place rapidly. Again C2H5Cl with water, CCl bond is also stronger bond, so take more energy to break down. So, that is why it would not occur rapidly. C2H5Cl with sodium hydroxide, again CCl bond is slower, so this option is also incorrect. B option is correct. Question number 24, structural isomerism and stereoisomerism should be considered when answering this question. Structural and stereoisomerism. A colorless liquid C5H11Cl exists as a mixture of two optical isomers. Okay. Structural isomerism and stereoisomerism both are present. Should be considered when answering this question. A colorless liquid C5H11Cl exists as a mixture of two optical isomers. This is the mixture of two optical isomers. When heated with sodium hydroxide in ethanol, a mixture of only two alkenes is formed. What could the colorless liquid be? So, CH3, CH2, 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 1, 2, 3, 4, and CH, mean to say this is CHCl, and this compound is like this. CH3, CH2, CH2, CH3, and Cl is there. When heated with sodium hydroxide and ethanol, a mixture of only two alkenes is formed. So, if remove this is elimination reaction. If write down like this, so this HCl is formed. When HCl is formed over here, so
ब्लड प्रेशर चेक किए हैं, ब्लड प्रेशर वगैरह चेक किए, ब्लड प्रेशर चेक करवा लीजिए।
This is elimination reaction. Elimination reaction, two optical isomers mean chiral carbon. They have given the colorless liquid. See, Cl, CH3, CH2, CH3. So exists as this is chiral carbon. So this is so there is not chiral carbon, as this is the one group and the same two groups are present on the both sides. So this is incorrect. CH3, CH2, Cl, CH3, CH3, CH2, CH2, CH, Cl and CH3. This is chiral carbon. This is chiral carbon, mixture of two chiral carbon. So this compound only CH3, CH2, CH double bond, CH3. So and the compound which is formed CH3, CH2, CH double bond, CH, CH3. This is cis trans 1 and 1, two isomers, and similarly CH3, CH2, CH2, CH and double. This is another isomer. Two products are formed, cis trans 1 and 2 isomers, and this is another isomer. When heated with sodium ethanol, mixture of only two alkenes is formed. Only two alkene is formed, so that's why it is incorrect. This is the mixture of 1, 2 and this is structural isomer also. So only two alkenes are formed. So this is incorrect. So next question, next option is CH3, CH, CH3, CH, Cl, CH3. So this is the CH3, CH, CH2 and CH and CH2. This is one and second is CH3, C double bond, CH and CH3. So this is not cis trans because two groups are present. So one is this and one is this. So C option, two alkenes are only, two alkene is formed, so that's why this option is correct. D option, so next question is, when warm water is added to halogen X and SN1 reaction occurs. Warm water is halogen SN1, it means it is primary haloalkane. It is primary haloalkanes if SN1 reaction occurs. AgNO3 is then added, yellow precipitate is formed. So 1-chlorobutane, yellow precipitate, it means iodine must be present, iodine is present in this haloalkanes, so this is incorrect. So 1-iodobutane, CH3 C CH3 CH3, iodine. So halogenalkane must be tertiary haloalkane, not primary. So AgNO3 is added, a yellow precipitate is formed. 1-chlorobutane, this is primary haloalkane, primary Cl, the structure is this, CH3 CH2 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 and Cl. So it is primary haloalkane, so that's why this option is incorrect. Iodobutane is also primary CH2, in primary haloalkane SN2 reaction occur, iodoid, so that's why it is not correct. 2-methyl propane, 2-chloro 2-methyl propane, Cl CH3 CH3 CH3. So this is also incorrect because chlorine, when silver nitrate is added, white precipitate is formed, so that's why it is incorrect. So next option, look at the next option, methyl propane. Two-iodo 2-methyl, iodine H, this is 2-iodo 2-methyl. So SN1 reaction occur because this is primary, and yellow precipitate is formed because iodine is attached with this carbon atom. So this option must be correct. Which alcohol will react with an acidified solution of potassium dichromate to produce ketone containing 6 carbon atoms? Ketones containing 6 carbon atoms. Which alcohol will react with acidified solution of potassium dichromate to produce a ketone? 2,2-dimethyl butane 1-ol, butane 1-ol, 2,2-dimethyl, CH3 CH3. H2, H2, CH3. 1, 2, 3, 4, 5 and 6. And ketone containing 6 carbon atoms. Ketone is formed. So this is primary alcohol. So ketone does not form. This is primary alcohol. Ketone is formed by secondary alcohol. So this is incorrect. Two methyl pentane 3-ol. 1, 2, 3, 4, 5. 2 methyl pentane 3-ol. CH3, CH3, CH2, CH3. 2 methyl pentane 3-ol. 1, 2, 3 all and 2 methyl. 1, 2, 3, 4, 5, 6. H. So CH3, CH2. This is secondary alcohol, so ketone is formed, or it contains 6 carbon atom. CH3, CH2, C double bond O, C CH3, CH3. 1, 2, 3, 4, 5 and 6. 6 carbon atoms and ketone group is formed. So this option is correct. Now look at the B. 3,3-dimethyl pentane 2-ol. 1, 2, 3, 4 OH. 3,3-dimethyl CH3, CH3, CH2, CH3, CH and CH3. 1, 2, 3, 4, 5, 6 and 7. So there is no 6 carbon atom, so that's why it is incorrect. And this is pentane 3-ol. 1, 2, 3 on 3 methyl CH3, CH2, CH3. So this is tertiary alcohol, so it is not further oxidized, so that's why it is incorrect. Question number 27, which statement about butanol is correct? Butanol can be dehydrated by concentrated sulfuric acid to give butanone. Butanol can be dehydrated by concentrated sulfuric acid to give butanol cannot be dehydrated to form alkene, this compound, so that's why it is incorrect. Butanol gives a positive result with Tollens reagent. This is incorrect. Give negative test. Butanol reacts with HCN by an electrophilic addition mechanism. This is not electrophilic, this is nucleophilic addition, so that's why it is incorrect. Butanol reacts with NaBH4 to give chiral product. Yes, butanol CH3, C double bond O, CH2, CH3 react with NaBH4 to give chiral product NaBH4 plus hydrogen atom. This is CH3 COH H CH2 CH3. Yes, this is chiral product. So this option is correct. Ethanol is used to make product R in 3-stage synthesis: CH3, CHO, HCN, NaCN. Product is CH3, CO, CN and H. H2SO4 HCN. Yes, this is OH. This product is OH. When H2SO4 reflux, this is converted into CH3 COH, and this is oxidized CO2H, and H. A few drops of concentrated sulfuric acid, a few drops product R, ester is formed. Because concentrated sulfuric acid, when react with product Q in the presence of concentrated sulfuric acid, ester is formed. Two molecules of Q react to give one molecule of R plus 2 molecules of water. Yes, 2 molecules of water. R has 2 ester functional group. This is a product R. CH3 CH, C double bond O, and because this 2 molecules of water plus 2 molecules of water, and this product is formed. 2 ester group, this is one ester and this is another ester group. So the empirical formula of this compound is 1 2 3 4 5 6 carbon atom and 4 oxygen, 3 4 5 and 3 8, C6H8O4, and the formula will be 3 4 2 C3H4O2. So this option is correct. Question number 29. The ester ethyl butanoate can be hydrolyzed using an excess of dilute sodium hydroxide solution. Which substance is a product of this reaction? Can be hydrolyzed using an excess of dilute sodium hydroxide solution. Ethyl butanoate, CH3 CH2 CH2 COO C2H5. This is ethyl butanoate. When using an excess of dilute sodium hydroxide to form CH3 CH2 CH2 CO2Na plus ethanol CH3 CH2OH. So which substance is a product of this reaction? CH3 CH2 CO2. This must be correct. CH3 CH CO2, this is ethyl This is sodium ethanoate, so it is not correct because butanoate salt is present. Ethyl butanoate. CH3CH2ON, it is also incorrect. Also incorrect. Water is the product, but which substance is product of this reaction? So this product is found when sodium react with ethanol. So water is not correct because two products are sodium butanoate and ethanol. So that's why water is also incorrect. The infrared, question number 30, infrared spectrum of an organic compound is shown. Transmittance. This is transmittance and this is wave number per cm inverse 1. This is the peak of CH, that is at 2950, and this is peak of carbonyl group at 1700. Which compound could give this spectrum? CH3CH2CO2H. So this is carboxylic acid, so OH peak is missing. At 2500 to 3000, sharp, very broad peak. 25 to 3000. So OH peak is missing. Carbonyl C double bond O is present, but OH peak is missing, so that's why it is incorrect. CH3CHOH, again OH peak is missing, so that's why it is also incorrect. CH3C double bond O CH3, so CH peak is there and C double bond O peak is there, so that's why it is correct option. CH3 CO CH2 OH, so OH peak at 3200 to 3000, 3600, peak of OH is missing, so that's why it is also incorrect. C double bond O peak is present, but OH peak is missing, so that's why it is also incorrect. So section B, question number 31. For complete combustion, 1 mole of an organic compound X requires 2.5 moles of oxygen. Which compound could be X? Complete combustion of 1 mole of an organic compound X requires 2.5 moles of oxygen. Which compounds could be Xc2H5OH plus O2 to form carbon dioxide plus water, 2, and this is 3 moles, so it is incorrect. C2H2 plus oxygen to form carbon dioxide plus water, this is 6 moles, 2 moles and 2 moles. Two CH2, just wait. C2H2 plus oxygen, carbon dioxide and water. 2 there, 2 and 3, 1.2 hydrogen, 2 carbon, 2 to the 4, 4 and 5, so 2.5 moles are there. This is correct. CH3 CHO plus O2 to form CO2, water 1 and 2, and 3 1 4 2 to the 4, 2 and 2 4 and 2 6, 3 moles. Sorry, not 3 moles. This is not 3 moles. This is 2 and 3 oxygen and 2 to the 4 and 2 6. 2.5 to 2 5 moles and 1. So this option is correct. If 2 and 3, then C option is there. In which pairs do both species have the same number of electrons and same number of electrons? This is 17 17. Chlorine is 18 because negative charge 18, 1 2, and potassium is 18, argon is also 18. This is 18 number of electrons, both cases. A option is correct. Question number 33, for which reaction does the value of delta H represents both a standard enthalpy change of combustion and a standard enthalpy change of formation? Standard enthalpy change of formation, both standard enthalpy change of combustion and standard enthalpy change of formation. Standard enthalpy change of combustion is defined as 1 mole of a substance is reacts with excess of oxygen to form carbon dioxide, and enthalpy change of formation, 1 mole of compound is formed. 1 mole of compound is formed. So 1 mole of compound is this, 1 mole of substance. So this is formation. 1 mole of substance is formed in their standard states under standard conditions. So 1 mole carbon solid, carbon over here. So this is enthalpy change of formation and this is enthalpy change of combustion. So this option is correct. Statement: 2 carbon plus oxygen, 2 CO. So over here 2 moles of substance is formed. So in case of delta HF, 1 mole of substance is formed. 1 mole of substance is formed. So this is not enthalpy change of formation. This is incorrect. Carbon monoxide, carbon dioxide. 1 mole of substance is formed from its constituent element. So this is not element, this is compound. So that's why third is also incorrect. So if 1 is correct, then D option is. Question number 34, the temperature of reversible gas reaction is increased. Which statement are always correct? Mode product is the temperature of reversible gas phase is increased. Which statement are always correct? Mode product is present at equilibrium. So this is correct in case only for endothermic reaction, not for exothermic reaction. The average speed of the particle increases. Yes, average particles, by increasing the temperature, average speed of the particle increases. There are more successful collision per unit. This is also correct because there are more successful collisions per unit time. So is 2 and 3 are correct, then option is C. Question number 35, the sample of chlorine gas each contain 0.710 gram of ethene. Each sample is reacted with the reagent. In the first reaction, sample is reacted completely with hydrogen gas. In the second reaction, sample is reacted completely with the cold sodium hydroxide. So this is completely with hydrogen. In first reaction, a sample is reacted completely with hydrogen gas, Cl2 plus H2 to form 2HCl. In the second reaction, sample is react completely with cold, Cl2 sodium hydroxide to form NaCl plus NaClO plus water, and in this case Cl2 plus sodium hydroxide to form NaCl plus NaClO3 plus water. So 0 gram of 0.710 divided by chlorine, so it's 71, so this is 0.01. So gram of HCl form in the first reaction. So 1:2, 0.1:2, 0.01:x, 0.70 gram. Which masses of the named product would be formed? 0.01 into 2 is equal to 0.02, and it is 71. Sorry, HCl is 36.5. The answer is 0.02 into 30, 0.02 into 36.5. Zero point 0.02 into 36.5, so 0.73 is the answer. This is correct statement. 0.585 in case of sodium chloride. So 0.01 ratio into 58.5 is the MR of sodium chloride. So the answer is 0.585. So in third case 0.01. So to balance this reaction, 3, 5 and 3:5, and this is 0.01 ratio x. The answer is 0.01 into 5 divided by 3 is equal to, this is 0.016 into 58.5. 0.016 into 58.5, which is 0.975. This is correct, this is correct. So if all statements are correct, the option is A. The option is for this reaction is A. Question number 36. Solid barium oxide is added to some ammonium sulfate solution, barium, solid barium oxide, in a test tube and the mixture is warm. A piece of damp red litmus paper is held over the mouth of the test tube. Which observations would be made? The damp red litmus paper initially turns from red to blue. Barium oxide plus ammonium sulfate to form barium sulfate and ammonia. So initially turns from red to blue. So ammonia gas turns damp red litmus paper blue. A white precipitate forms in test tube barium sulfate. White precipitate of barium sulfate is formed in this reaction. So this is also correct. Brown gas is evolved with strong heating. Brown gas is not formed because if ammonium nitrate is there, then from the nitrate or nitrite ion, brown gas is evolved when strong heating. This is nitrogen gas, and nitrogen gas is not formed in this reaction. Okay, so this is incorrect. B option, ammonium nitrite is there, then 2 from ammonium nitrite nitrogen dioxide is produced. Which compound show geometrical cis-trans isomerism? CH3 C H double bond C H3 C2 H5. Yes, cis-trans isomer is there because double bonded carbon surrounded by two different groups, in this on this side and on this side. This is correct. CH3 double bond over here, so different groups also show geometrical isomers. C2H5CH, C2H5CH, so same groups are present with double bonded carbon. Different groups. Each double bonded carbon must have two different groups, like CH C2H5 double bond CH C2H5. So it must have cis-trans isomers. This is also correct. So A option is for this reaction. Which pairs of compounds may be distinguished from each other by testing with alkaline aqueous iodine? Ethane 1,2-diol and ethanol. CH3 CH2 OH. So this does not show so can be differentiated by using alkaline aqueous iodine and ethane 1,2-diol. It can be differentiated. Ethane, this is second compound, ethane 1,2-diol, CH2 OH OH
जल्दी लाना जरा हॉटपॉट पड़ा है असद के पास, वो ला लो। आयशा किधर गई?
This is oxidized to form carboxylic acid. This is also oxidized by alkaline aqueous iodine. So cannot be differentiated by using alkaline aqueous. So C option is correct because this will give, both will give positive test with alkaline aqueous iodine. Only this cannot give, differentiate. These two compounds cannot differentiate it by using alkaline aqueous iodine. But these two compounds can be differentiated because this is like this. OH CH3. It will give positive test with alkaline aqueous iodine. But methyl propane 2-ol, this is methyl propane 2-ol, CH3 OH. This is tertiary alcohol, so it will not give the positive test with alkaline aqueous iodine. So that's why C is correct. Question number 39. The diagram shows an experimental setup which can be used in several different experiments. This is liquid X. Silica, alumina are baked. Clay, gas collected. Liquid X can be, this is dehydration of ethanol apparatus, and C2H4 is formed. So dehydration of ethanol X or cracking of paraffin. In both cases C2H4 is formed. So 2 and 3 oxidation of ethanol produces, oxidation of ethanol gives ethanoic acid, so it is not correct. No gas is there, so in both cases C2H4 gas is formed which is collected in this apparatus. Question number 40. The ester C2H5 propanoate can be made in school or college laboratory by a sequence of 4 reactions or fewer using compound Z as the only organic product. Z as the only organic product. What might be the identity of compound Z? Can be made in school by a sequence of 4 reactions of fewer using compound Z. This is alcohol which react with carboxylic acid to form ester. This is correct. CH3, this is aldehyde. First alcohol to carboxylic acid and then ester. Aldehyde to carboxylic acid and then ester. First alcohol is oxidized to carboxylic acid and then it reacts with alcohol to form ester. Aldehyde is oxidized to form carboxylic acid and aldehyde is dehydrated to form aldehyde is reduced to form alcohol, so it reacts with carboxylic acid to form ester. So B option is correct. Ketone cannot further oxidize, so that's why it is incorrect. Hopefully you got it. If you have any queries in this paper, you can ask in comment box.